All right, let's get right into it. AI coding assistants are pretty much everywhere now, right? But here's the thing. The code they spit out, it isn't always ready for prime time. So in this explainer, we're going to break down exactly how you can transform that machine-generated output into a high-quality, human-centric asset that your team can actually work with.
And this is a really serious question to ask yourself. Because while these AI tools are amazing for productivity, they can also quietly, litter your code base with generic, hard-to-maintain code. And this isn't just about looks. It's a hidden cost. It's technical debt that can really slow you down later. So, what do we do about it?
Well, we've got a clear game plan. First, we'll unpack the hidden costs. Then, we'll look at the big differences between machine and human code. After that, it's the main event, a 3-stage playbook to convert it. We'll wrap up with the essential tools you'll need and how to future-proof your whole approach.
Okay, first up, let's really set the stage for why this is so critical right now.
This right here, it just nails it. This isn't a nice-to-have skill anymore, not by a long shot. As AI gets baked into all of our workflows, being able to refine its output is what's going to separate a project that's fast but fragile from one that's actually built for the long haul, for real team collaboration.
So, to solve this problem, you first have to understand it. Let's take a look at what makes AI-generated code so different.
At a high level, the differences are pretty stark. AI code, it's often very predictable, very repetitive. It works, sure, but it has zero context. Human code, on the other hand, it's more creative, it's adaptable, because it's built with a much deeper understanding of the specific problem it's trying to solve.
And this breakdown shows you exactly what I mean. Just look at variable naming. An AI might give you data or result. I mean, it's technically correct, but it tells you absolutely nothing. A developer, though, they use names that reflect real domain knowledge. And you see the same thing with error handling. The AI does the bare minimum, while a human builds in robust, custom logic.
And here it is. This is the perfect example of a black box. The function is called process data, okay, but what data? And why are we processing it? This code works, yeah, but its purpose is a complete mystery without a lot of digging. This right here is where technical debt is born.
So how do we crack open that black box and make it clear and maintainable? Well, that brings us to our 3-stage conversion playbook. Think of this as your systematic guide for turning that raw AI output into truly production-quality code.
It's a really simple but powerful framework. First, you assess what you've got. Second, you enhance it. And third, you validate that your changes actually meet the quality bar. Assess, enhance, validate. Simple as that.
Let's start with stage 1. Before you change a single line of code, you have to assess the situation. This means spotting those classic AI patterns, like the generic variable names we saw. You'll also want to use static analysis tools, think SonarQube or ESLint, to get hard data on things like complexity and code smells. This isn't about feelings. It's a data-driven diagnosis. Okay, so once you've assessed the code, you get to stage 2, enhancement. And the whole goal here is to transform that generic black box into something that looks like this, code that actually tells a story. We're not just processing data anymore, no, we're filtering sales figures for a bonus calculation. This is the target. It's clear, it's specific, it's self-documenting.
So, how do we get there? Well, the whole transformation really boils down to these key changes. We give the function a meaningful name that says what it does. We add documentation, a docstring, to explain the why. And we use descriptive variables so the business logic just shines through. It's all about adding semantic clarity.
And the how, the nitty-gritty, comes from applying these core software craftsmanship techniques. This is way deeper than just renaming things. You're going to use classic refactoring like extract method to keep your functions small and focused. You'll hunt down redundant code. You'll simplify crazy logic. And this is a big one, you'll add the security and maintainability features that AI almost always misses, like input validation.
And finally, we land on stage 3, quality assurance. You can't just assume your changes were good. You have to prove it. That means running automated checks in your CI/CD pipeline, doing human code reviews that are specifically looking for leftover AI weirdness, and, of course, writing a full suite of tests. unit, integration, and performance tests to make sure the code is not just readable, but also correct and fast.
And what's the payoff for all this work? Well, you can actually measure it. Using a standard metric like the maintainability index, that generic AI code might score a 45, which is firmly in the hard-to-maintain zone. After this process, it can jump all the way up to an 85, which is considered easy to maintain. That's not just a nice feeling, it's a real quantifiable boost to your team's velocity.
Okay, so you've got the playbook. Now let's talk about the gear. What tools do you actually need to pull this off?
For that critical first assessment stage, these are going to be your best friends. You've got platforms like SonarQube that give you that 10,000-foot view of code health. Then you have your language-specific linters like ESLint for JavaScript or PyLint for Python. And of course, automated formatters like Prettier and Black. They just handle the easy stuff for you. Then, for the enhancement and QA stages, your toolkit gets a bit bigger. Your IDE's built-in refactoring tools, they are your secret weapon. You lean heavily on testing frameworks to build out that validation suite, and then you tie it all together with your CI/CD integration to automate those quality gates so nothing substandard ever makes it into production.
So the tools and techniques are fantastic, but how do you make this a lasting practice for your team? Especially when the AI itself is getting better and better.
At the end of the day, it's about building a culture. You have to create clear guidelines for how your team handles AI-generated code. Document common refactoring patterns in a knowledge base. Set up those automated quality gates we talked about to act as a safety net. And maybe most importantly, keep an eye on your metrics and stay up to date. AI is a moving target, so our strategies have to evolve right along with it.
You know, this quote just sums up our entire playbook perfectly. There's no magic bullet here. Success comes from a systematic approach. You have to combine that initial technical assessment, these smart strategic enhancements, and that rigorous final validation. Assess, enhance, validate. That's the formula.
And that leaves us with a really fascinating question to think about for the future. As these AI models get so good that their code starts to look more and more human, will this translation skill become obsolete? Or will the ability to spot those subtle context mistakes, to apply that deep domain knowledge, actually become an even more critical, high-value skill for all of us? It's definitely something to chew on.